Okay, so we're ready for the next level of difficulty, but it's not too hard. So this is the case where we have something in the form of the integral of sine to the m of x times cosine to the n of x with respect to x. And one of those exponents is odd. Could be both. Okay, the word or means m could be odd, n could be odd, or they could both be odd. But they're not going to be equal to 1, because if they were equal to 1, we would be looking at a level 1 problem. We just do straight U substitution, right? But our goal is to create a level 1 problem. Okay, so goal is to create a level 1. And once we create a level 1 problem, we can use U substitution to force it to be something on the memory list. So we were driving back to the memory list, to the things that we know. So let's do a couple of level 2 problems. But before we do, we need to remember an important trig identity. So here's the trig, also known as a mathematical identity. This is one that you should be very familiar with. Okay. Now, the implication of this, we're not going to use that form of the trig identity directly. The implications are that if I were given a sine squared of x, notice that's an even power of sines, I could rewrite it as 1 minus cosine squared of x. So I could rewrite things in terms of sines, in terms of cosines, or I could say that cosine squared of x is equal to 1 minus sine squared of x. So we're going to be using these two forms to convert even powers of either the sine or the cosine, depending on what we need to use at the time, into the other. So let's go ahead and do this for a couple of problems. Okay, so let me start with example 1. Let's integrate the cosine cubed of x dx, right? Now you might be tempted to try U substitution. If you let, this isn't going to work, so don't copy this down. If you let U equal cosine of x, du dx will end up being negative sine of x, and this will just never cancel out. Okay, there's no way to get that to cancel out, so it would be nice to have a U cubed, but the derivative part won't do any canceling. It will just add complexity that we would have to undo. So let's not do that. Right? We need to rewrite this. Okay. So the way we're going to rewrite this first is to rewrite this as the integral of cosine squared of x times cosine of x. So notice what we've done. We're on our way towards level 1. We have a cosine of x to the first power. So level 1 involves either having a sine or a cosine to the first power. So we've drawn a single power of cosine out, and what we're left with is cosine squared. All right. We would like for that to be sines instead of cosines, because if it had sines in it, the derivative would be a cosine. So we'll make it work. We'll rewrite that part as 1 minus the sine squared of x times cosine of x dx, right? Now you might find it easiest at this point to think of this as two different integrals, all right? So we would have the integral of 1 times cosine of x, which is just cosine of x dx. You could leave it in one integral and just have a more complicated antiderivative, but I sort of prefer to break it into two simple problems. So the first problem, this is just a memory list, all right? The second problem is one that we just did, or it's very similar to one that we just did. So notice cosine of x is to the first power, so we're going to want to substitute for the sine of x. So du, I'm going to go right to cosine x dx. So we have du in that integral, and we'll have a u squared. So we can rewrite this whole thing. I'll do all the integrating at once, so I'm just going to bring the cosine of x dx down, and we will have minus the integral of u squared du right here. Okay, and now we're ready to integrate, and we can say, this is equal to the antiderivative of sine, I'm sorry, of cosine is a positive sign, and then we'll have minus u cubed over 3 plus c. Obviously, we don't want to have x's and u's in here, so let me just write this on the same line. This will be the sine of x minus 1/3. U was the sine of x, sine cubed of x plus c. That is our answer. Okay, so that is the antiderivative of cosine cubed of x dx. If you want to do a quick check, you would take the derivative of all of this. So if you take the derivative of what we just got, so the derivative with respect to x of our, I'll just say answer. If you look at the first term, you'd have a cosine of x. Then you would have minus, you would be using a chain rule here. So you would have a 3 sine squared of, I'm sorry, 3 times a third drops it down. So just a 1. So you get rid of the coefficient, and then you'd have a sine squared of x. But then you'd have to multiply by cosine of x. And the derivative of the constant is 0. Oh, so that's cosine of x times 1 minus sine squared of x, which we know is cosine of x times cosine squared of x, which is in fact cosine cubed of x. So it did in fact work, right? Let's do 2 more examples. I won't do the check on all of the examples, but you can always check by taking the derivative of your answer. Make sure you get back to your integrand. So our second example is the sine squared of x times the cosine cubed of x dx. All right, so what we want to do is draw one factor of the odd exponent out. Okay, so notice we have an odd numbers of cosines. So let's do the same thing we did before. We have this sine squared. We can't pull a single factor of sine out of that and use the identity that we just had because the identity involves squares. So let's leave the sine squared of x alone. That's the one we can't simplify, but we can rewrite cosine squared, cosine cubed as cosine squared times cosine to the first. And the key is we now have something that's starting to look like a level 1 problem if I convert the cosine squared of x using my identity. So let's keep going. Oh, I should have an equal sign on the left here. We'll leave sine squared of x alone. Cosine squared of x can be rewritten. Since it's even, we can rewrite it using our Pythagorean identity. Just do some distribution. We end up with the integral of sine squared of x minus sine to the 4th power of x all times the cosine of x. Probably the easiest thing to do is write this as 2 different integrals. They're going to be very similar, minus the integral of sine to the 4th of x times cosine of x dx. For the first one, whoops, let me change color here. We'll let u equal the sine of x, just like we did before. We want to leave cosine of x alone because that's what the, to the 1st power, so du, I can go right to du. Eraser out here. So as in the previous problems, du will be cosine of x dx. We can see we have that right there. So the first integral converts nicely. And by the way, this is a perfect problem where we could let u equal sine of x in the second integral, and we would have a du right here. So we can rewrite both of them at the same time. So it just happens to work out that way. So we can say u squared du is the first integral minus the integral of u to the fourth du. If we had limits, now would be the time to convert them. So this is unlike integration by parts where we just take the limits off and put them back in at the end. I would actually convert the limits here. Do we have the right colored pen? Yes, we do. Okay, so this becomes 1/3 u cubed, or u cubed over 3, minus 1/5 u to the 5th, or u to the 5th over 5, plus c. Obviously, we don't want to leave it in terms of u. Remember u, got to remember which one you use. It was sine in this case. So 1/3 sine cubed of x minus 1/5 sine to the 5th of x plus c. That is our answer. Okay. Let us do just one last example. If you didn't follow it, you feel free to pause and rewind the video and just freeze the screen if you need to look at any of these examples for longer. So let me go through example 3. Okay, so you can see in this case, both powers are odd. So we really have the choice of doing it either way. I tend to like to let u equal the sine of x because the derivative is nicer. We don't introduce a negative sign. So I'm going to stick with what we've been doing. So we'll redo this one exactly like we did the last problem, where we will rewrite. You could do it either way. So I'll highlight what we could do. So this is what we have been doing. We could have done this. I'm not going to do this. I'll stop with this step. I could have rewritten this as sine of x times sine squared of x, cosine cubed of x dx. And I could use the trig identity to rewrite the sine squared as 1 minus cosine squared. I just have a preference for drawing a cosine out by itself. I prefer to have cosine of x to the first power, but this would have left you with sine of x to the first power. You'll end up with the same answer, whichever one you do, provided you don't make any errors. So following the same logic that we've been doing, we can rewrite this as the integral of, whoops, I left an x out up there, the sign of a variable, and then we would rewrite this as 1 minus sine squared of x times cosine of x with respect to x. So the key was right here. Oops, I got to change colors. This was rewritten in terms of the trig identity. So then we can rewrite this. I'm going to go right to having two integrals. The first will be the sine cubed of x times cosine of x dx, minus the second integral would have sine to the 5th of x cosine of x dx. All right, so making the same substitution that we've been making. Obviously, if we use this one, we would end up letting u equal cosine of x and going from there. But in this one, we're going to let u equal the sine of x, which is actually going to be nice for both of these integrals. So du will again be cosine of x dx. So both of these have a du. If you use this one up here, you would have du is equal to a negative sine x dx. So you would have to introduce a double negative sign in order to get things to work out nicely. So I prefer the method I'm doing here. Let's keep going with this. All right, so this is equal to the integral of u cubed du minus the integral of u to the 5th du. Antiderivatives, just 1/4 u to the 4th minus 1/5, I'm sorry, 1/6 u to the 6th plus c. Raise those powers by 1. then just rewrite it 1/4 sine to the 4th of x minus 1/6 sine to the 6th of x plus c. One final note, if you had done the other method over here, since we let u equal cosine of x, we would have the whole thing expressed in terms of cosines instead of sines. But if you were to take the answer you get from here and everywhere that you have a cosine squared of x, you rewrote it as 1 minus sine squared of x. And that would mean if you had a cosine to the 4th of x, it would be 1 minus sine squared of x squared. Cosine to the 6th of x would be 1 minus sine squared of x cubed. If you rewrote it all in terms of sines and then condensed your constants down and compared your answers, you would see that the two answers do match. So they do look very different at first if you choose the alternate method. But you might have to do that if you do it one way and the book does it the other way. You might have to compare your answers by sort of subbing back to see, by using the trig identities to get the two answers to match up. Okay, so you should be in a good position now to do those homework problems that I've assigned.